In this video, we are going to revise Oceanography. Hello friends, welcome to the Tapasya for IAS YouTube channel. So let's begin Oceanography. Oceanography, study of oceans physical, chemical, geological, and biological aspect. Significance, it covers nearly 71% Earth, 97% global water, climate regulator, resource provider, environmental indicator. Crust, oceanic, thin, dense, young basalt versus continental, thick, less dense, old granite. Oceanic relief feature, major feature, continental shelf, shallow, 100 to 200 meter, gently sloping, formed by sediment, rich in fisheries, Grand Bank, Dogger Bank, oil gas, Bombay High, North Sea. White, where plains meet sea, narrow near mountain. Next is continental slope, steep, 200 to 3000 meter depth. Connects shelf to deep sea, often cut by submarine canyons. Continental rise, general slope, at slope base, accumulation of sediments. Abyssal plains vast, flat deep sea plains 3000 to 6000 meter, covers nearly 76%. Ocean floor formed by fine sediment. Minor features, trenches, deep, narrow depression at subduction zone. Example, Mariana Trench. Deepest, Puerto Rico Trench, associated with earthquake volcanoes. Mid-oceanic ridge, submarine mountains, ranges at divergent plate boundaries. Example, Mid-Atlantic ridge longest. Seamount goats, goats. Underwater volcanic mountain, seamount. Pinnacle, goats flat topped due to wave erosion before subsidence. Submarine canyon, V-shaped valley on slope, self slope, found by turbidity, currents or relict, river valleys. Next is bank solas. Shallow elevations good for fishing. Bank solas are navigation hazard. Coral reef, CSO3 carbon, calcium carbonate, structure by polyps in warm, shallow, clear, moderate salinity water. Types, fringing close to coast, barrier, parallel, wide lagoon, great barrier reef, atoll circular enclosing lagoon, Lakshadweep. Threats, coral bleaching, warming, acidification, pollution. Significance, biodiversity, shoreline protection, tourism. Ocean deposits, sediments, lithogenous, terrigenous. From land erosion, rivers bends, dominant near continents. Biogenous from marine organism. Plankton cell, dominant in deep ocean. Ooze, 30% biogenous. And calcicarous, CSO3 or siliceous, SiO2. Hydrogenous chemical precipitation from seawater. Example, manganese nodules. Evaporites. Cosmogenesis, extraterrestrial cosmic dust. Distribution, thick near shelves, thin absent or mid-oceanic ridge. Major ocean, size, depth, key features. Pacific, largest, nearly 47%. Deepest, 390 cm average. Challenger Deep, Ring of Fire. Atlantic, second largest, nearly 24%. S-shaped, mid-Atlantic ridge. Indian, third largest, nearly 20%. Northern Hemisphere landlocked, monsoon-driven currents. Southern Antarctic. Around Antarctica, significance upwelling. Arctic, smallest, nearly 4%. Shallowest, 1205 meter average. Low salinity, ice covered. Salinity, dissolved salt. Definition, average 35 ppd parts per thousand, mainly NaCl, sodium chloride. Factors, increases evaporation, tropics, ice freezing. Decreases precipitation, equator, river runoff, coast, ice melting, also by winds and currents. Distribution: horizontal highest in subtropical high pressure belt, 20 to 30 circulation latitude. Then is very high in enclosed seas, Red Sea 42 ppt, Dead Sea 200 ppt. Very low in Baltic Sea 7 ppt. Vertical, variable at surface, halocline 100 to 400 meter. Is zone of rapid salinity, increases. Deep ocean salinity stable. Significance: affects water density, driving currents. Freezing point, marine life. Temperature of ocean water. Factors: latitude decreases from equator 27 to poles 0. Depth decrease with depth. Currents: warm currents raise, cold current lower temperature. Winds cause upwelling of local water, upwelling of cold water. Distribution: horizontal, highest in enclosed tropical seas. Higher annual range in NH. Vertical, 3 layers in mid-low latitude, warm surface 0 to 500 meter. Thermocline 500 to 1000 meter, rapid trough. Cold deep layer. Significance: control climate, navigation, ice-free ports, fisheries, convergence zones. Ocean movement: waves, tides, currents. Waves: wind-driven oscillatory motion, energy moves, not water vertical. Height depends on wind speed, duration, fetch. Break in shallow water, sways backwards, causing coastal erosion. Tsunami is large wave from seismic events. Tides: periodic rise, flood, and fall. F. Up sea level average nearly 12-hour 26-minute cycle. Causes: moon's gravity primary, sun's gravity. Centrifugal force types: frequent semi-diurnal to equal, diurnal 1, mixed to unequal. Alignment: spring tides. High range full new moon, aligned sun moon earth. Neap tides low range. Quarter moon sun moon at 90° circulation. Tides bow: wave of river during strong incoming tides. Example, Hooghly. Significance: adds navigation like in London, Kolkata ports. Desilting, fishing, tidal energy, Durga Duani. Ocean currents: continuous directed movement of ocean water. Types: surface wind driven up top nearly 400 meter. Deep water, density driven, thermohaline. Warm current, equator to poles. Example, Gulf Stream, Kuroshio. Cold current, poles to equator. Example, Labrador, Humboldt, Peru, and Venezuela. Factors: insolation, gravity, temperature, salinity, density. Coriolis force deflects RNH, LSH. Land masses, planetary winds. Major gears. Example, North Atlantic gears clockwise. Indian Ocean, monsoon driven in northern hemisphere. Southwest monsoon drift in summer. Northeast monsoon drift in winter. Significance: regulate global climate, warm cool coast. Aridity, major fisheries. Upwelling, convergence zones, influence navigation. Thermohaline circulation, global conveyor belt. Deep ocean currents driven by temperature and salinity difference. Cold salty water shrink at poles, crucial for global heat nutrient distribution. So this was the end of the lecture. We will meet in the next video. If you have any doubts, ask in the comment section. Subscribe to the channel and like the videos. Don't forget to press the bell icon so that UPSC focused videos keep reaching you. Thank you for watching. Jai Hind.